Hi everyone. Today in this module we are going to discuss 2024 March stream CBSE Grade 12 board examination questions from probability from different sets like 65 of 5 of 1 and 65 of 4 of 1. See what kind of questions were given in this board examination. Coming to the very first question, like it is a multiple choice question. 18th one, if A and B are given such that probability of A given B is equal to probability of B given A, then which of the following is the correct option? You just have to follow the definition of probability of A given B. What is the formula for probability of A given B? Probability of A intersection B divided by probability of B, which is equal to what is probability of B given A? Probability of B intersection A divided by probability of A. But you know, probability of A intersection B is equal to probability of B intersection A. Both can be cancelled. Therefore, probability of B is equal to probability of A. So, probability of B is equal to probability of A. But you cannot go ahead with A is equal to B because we do not know what are the two events A and B, but their probabilities are same. Therefore, P of A equal to P of B is the correct option. Right? So, coming to the next question, 31st question means it carries how many marks? 3 marks. Yes. So now the random variable x has the following probability distribution where a and b are some constants. See, whenever you are given probability distribution, then you know that sum of all the probabilities is going to be 1. So sum of all the probabilities means what? 0.2 plus a plus 1 more a plus 0.2 plus b is equal to 1. Right? So 0.2 plus 0.2 is 0.4 plus a is equal to 2a plus b is equal to 1. So from this, what is 2a plus b? 2a plus b is equal to 1 minus 0.4 is going to be 0.6. This is one information, and one more information is given. What is that? The mean expectation of x is equal to 3. What do you mean by expectation of x? Expectation of x is nothing but expectation of x is equal to sigma xi into p of xi. This is what is expectation of x, which is given 3. So xi into p of xi means, 1 into 0.2, 1 into 0.2 plus 2 into a plus 3 into a plus 4 into 0.2 and then plus 5 into b is equal to how much? Which is equal to 3. So when you simplify, 1 into 0.2 is going to be 0.2. This is 2 into a, 2a plus 3 into a, 3a. 2a plus 3a is equal to 5a. And then 4 into 0.2 is going to be 4 2s are 8. So 0.8 plus 5 into b is 5b is equal to 3. Now say 0.2 plus 0.8 is equal to 1. So finally what do you get? 5a plus 5b is equal to, this is 3, this is 1, 3 minus 1 is equal to 2. So 5a plus 5b is equal to 2 is the second equation and this is the first equation. So from this first equation, even if you multiply by 5a, multiply by 5, 5 into 2 is equal to 10a plus 5 into b is 5b. 5 6 are 30, right? Which is going to be 3. I am writing that here. This is 10a plus 5b is equal to 3. I am going to eliminate b terms so that this is 10a minus 5a is equal to 5a, which is equal to 3 minus 2 is equal to 1. So 5a is equal to 1, then the value of a is equal to 1 divided by 5. So when a is equal to 1 divided by 5, how to get the value of b? We can substitute one in one of the equations. Say this is 2a plus b is equal to 0.6, right? Then b is equal to 0.6 minus 2a. 2 into 1 by 5 is equal to 2 by 5. So which is equal to 6 5s are 30 means 3 minus 2 is equal to 1 divided by 5. Therefore, the value of b is equal to 1 by 5 and the value of a is equal to 1 by 5. So and hence find the values of a and b. Also determine probability of x greater than or equal to 3. What do you mean by probability of x greater than or equal to 3? See here x greater than or equal to 3 means from 3 and above. So you have to find this probability. So probability of 3 and above means this is going to be a plus 0.2 plus b. What is a plus 0.2 plus b? A plus b value you already know, a is equal to 1 by 5, b is equal to 1 by 5. So 1 by 5 plus 1 by 5 is equal to 2 by 5 plus 0.2. What is 2 by 5? 2 by 5 is equal to 5 fours are 20 plus 0 0.2. 0 0.4 plus 0 0.2 is equal to 0 0.6 is probability of x greater than or equal to 3. Right? So this way you can answer this problem. This carries 3 marks. So coming to the next problem, which is a 38th question. It's a case study based question. So when you answer this particular problem, you see what is the information given in the problem. So for that, I am going to erase this particular area. Now see that. The problem given here is a departmental store sends bills to charge its customers once a month. So past experience shows that 70% of its customers pay their first month bill in time. So if 70% of the customers pay their first month bill in time, then can you tell me what is the probability of the customers pay their first month bill on time? Yes, we can easily identify that. So here E1, what is E1? E1 be the event of customers paying first month bill. So I'm directly starting here. E1 is the customers paying the first month bill. Therefore, what is P of E1? P of E1 is equal to on time 70%. So 70% is nothing but 70 by 100, which is equal to 0.7. If percentage of the customers paying the first month bill is 70%, then what is the percentage of the customers not paying the bill on time is obviously 30%, right? So then that is E2. Therefore, probability of E2 is equal to 1 minus 0.7, which is equal to 0.3 or 30%. Anything is fine. And coming to A, let A denote the event of customer paying the second month bill in time. Okay, so A percentage or event of selecting customers paying second month bill on time. So second month bill on time. So second month bill on time, then what is the probability of paying second month bill on time if they pay the first month bill on time? That is what P of A given E1. I think it was given clearly. The store also found that the customer who pay the bill in time has the probability of 0.8 of the 8 of paying in the next month bill, right? So it is going to be 0.8. And what is probability of A given A2? That information also given, which is going to be 0.4. So now what are you asked to find? First one is let E1 and E2. Then what is probability of E1 comma probability of E2? Yes, we know probability of E1 is 0.7, probability of E2 is 0.3. And next one, A denotes the event of customers paying. Then what is probability of A given E1? 0.8, A given E2 0.4. Now coming to the third question. What is third question? Find the probability of customer paying the second month bill in time. Paying the second month bill in time means P of A is equal to how much? So P of A is nothing but you need to find out the total probability. So what is the formula for total probability? P of E1 into P of A given E1 plus P of E2 into P of A given E2. So this is what is the total probability, which is equal to P of E1 is 0.7 into probability of A given E1 is 0.8 plus P of E2 is equal to 0.3 plus P of A given E2 is equal to 0.4. So when you simplify, 7 8s are 56. So 0.56, 3 4s are 12. So 0.12, which is going to be how much? 0.56 plus 0.12 is 0.78, right? So this is what is the answer for third problem. Find the probability of customers paying the second month bill. Right. So there is an internal choice question given here. What is that internal choice question? Find the probability of customer paying the first month bill in time. If it is found that customer has paid the second month bill in time. So this is what conditional probability here. So in this conditional probability, you are asked to find probability of E1 given A. Why E1 given A? Because find the probability of customer paying the first month bill in time. That is probability of E1. It is given that customer has paid the second month bill also on time. So A is second month bill. What is the formula for P of E1 given A? Yes, you know that P of E1 into P of A given E1 whole divided by total probability, right? So what is the total probability? Total probability of P of A only, right? So P of E1 into P of A given E1, how much is that? E1 into A given E1 is 0.7 into 0.8 divided by how much you got? 0.78. So 7 8s are 56. So 0.56 divided by 0.78, which is equal to 56 divided by 78. So 56 divided by 78 can be simplified further. Yes. 4 14s are 56, and then 4 1s are 438. No, it is not. So can be cancelled by, okay, let us go ahead with some 2. 2 28s are 56, and 2 3s are 6, and 2 9s are 18. So 29 divided by 28 divided by 39 is the probability of E1 given A. All right. Yes, coming to the next problem. See, the 8th problem, which is a case study based question. If a departmental store sends bills to charge its customers once a month, past experience shows that 70% of its customers pay their first month bill in time. So the store also found that the customer who pays the bill in time has the probability of 0.8 of paying in time the next month, and the customer who doesn't pay in time has the probability of 0.4 of paying in time the next month bill. So it is understood that what is E1 and what is E2, but it was given clearly in the problem itself. Let E1 and E2 represent respectively denote the event of customer paying or non-paying the first month bill. So if E1 denotes the event of customer paying the first month bill, then what is probability of E1? It was given very clearly. Probability of E1 is equal to 70%. So 70% is nothing but 70 divided by 100, which is equal to 0.7, or else you can even write it as 7 divided by 10 also. This is probability of customers paying the first month bill. 0.7, already all of them are given points on, so it is 0.7. Then what is the probability of E2 not paying the first month bill in time? Is nothing but 1 minus 0.7. What is 1 minus 0.7? Is going to be 0.3. And where A denote the event of customer paying the second month's bill in time, then what is the probability of A given E1? It was also given clearly in the problem itself. You see, the customer who pays the bill in time has the probability of 0.8. So A given E1 is 0.8, and similarly, what is probability of A given E2? A given E2 is also given 0.4. So what are you asked to find? Then let E1, E2 respectively. Then find probability of E1, comma probability of E2. Yes, probability of E1 is 0.7 and probability of E2 is equal to 0.3. And the second question, A denotes the event of customer paying second month bill in time. Then probability of A given E1 is 0.8, A given E2 is 0.4. And what is the next problem? Find the probability of customer paying the second month's bill in time is nothing but you are asked to find the total probability, that is P of A. So P of A is equal to what? The theorem of total probability, we learned it, right? Probability of A is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. This is what is the total probability. So now we can substitute because all the values are available here. Probability of E1 is equal to 0.7 and probability of E2 is equal to 0.3. Sorry, probability E1 into A given E1. A given E1 is equal to 0.8 plus probability of E2 is equal to 0.3 plus probability of A given E2 is 0.4. Okay. Now when you simplify, 7 8s are 56. So 0.56 plus 3 4s are 12. So 0.12. So when you add both of them, what do you get? Probability of A. Probability of A is equal to 56 plus 12 is equal to 68. So probability of A is equal to 0.68. So this way we can answer Third problem, first bit. And what is the second bit given here? Second bit given was find the probability of customer paying the first month's bill in time. Means probability of in time is nothing but E1, right? Probability of E1 if it is found that customer has paid the second month bill on time. So you are asked to find probability of E1 given A. It means it is a conditional probability. You know the formula. What is probability of E1 given A? Probability of E1 into probability of A given E1 divided by total probability one, this is P of A, substitute values. P of E1 into A given E1. E1 into A given E1 is 0.7 into 0.8, that is 0.56 divided by 0, probability of A is equal to 0.68. So 56 by 68 is 56 divided by 68. So 56 by 68 can be simplified further. Let us go ahead with 2 2s are 4, 2 8s are 16, and 2 3s are 6, 2 4s are 8. Can be cancelled by one more 2. 2 1s are 2, 2 4s are 8 divided by 2 17s are 34. So 14 divided by 17 is probability of E1 given A. So this way we can answer 65 of 5 of 1 questions easily. I think almost all the questions are pretty much easier. Right. Coming to the next paper, that is 65 of 4 of 1. See, in this particular paper, we come across some problems which are comparatively easier because probability distribution problems are always there, where k is some unknown constant. So from this table, what is the probability of random variable x takes the value 2? So in order to get x takes the value 2 is nothing but you need to find 2k. In order to find 2k, you need to get the value of k, right? So for that, it is understood that sum of all the probabilities is equal to 1, right? So what is sum of all the probabilities? 0.1 plus 0.1. 0.1 plus 0.1 is 0.2 plus k plus 2k plus k is equal to, this is going to be 4k is equal to 1, right? So 0.2 plus 4k is equal to 1. Then 4k is equal to 1 minus 0.2 is 0.8. 4k is equal to 0.8. K is equal to 4 2s are 8, right? So k is equal to 0.2. Now you are asked to find the probability that the random variable x takes the value 2, x takes the value 2 is 2k. So probability of 2 is equal to 2k, which is equal to 2 into k is equal to 0.2, which is equal to 2 into 2 by 10 because your answer is on fractions. So 2 ones and 2 5s are 10, which is going to be 2 divided by 5. So 2 divided by 5 is the required value. So coming to the next problem, which is a 3 marks question. 3 marks question has internal choice given here. So in this 3 marks question, a card from a well shuffled deck of 52 playing cards is lost. From the remaining cards of pack, a card is drawn at random and is found to be a king. So find the probability of the lost card being a king. So I think it is just similar to a textbook problem. Now a card from a well shuffled deck of 52 cards is lost. Now you are going to have events. So what are those events? E1 is event of last card is a king. Okay. So event of last card is a king. So event of last card is a king is nothing but we have 52 cards, right? Then tell me what is probability of E1? Probability of E1 is nothing but you are drawing a card. In fact, you are drawing a card which is a king from 52 cards. So what is the probability of drawing a king? It is 4 divided by 52. 4 divided by 52 is equal to 1 divided by 30. And what is the probability of not drawing not a king? Last card is not a king. Last card is not a king. Obviously 1 minus 1 by 13 is equal to 12 divided by 13. Now, when one king is already lost, means one card is already lost. One card is lost out of 52 cards, one card is lost, then you are left with now 51 cards. So what are you supposed to do? A card is drawn at random and is found to be a king. Find the probability of last card being a king. Probability of last card being a king is nothing but I am going to define one more event A. That event A is drawing a king now from 51 cards. Okay, so king event of drawing a king from 51 cards. So drawing a king from 51 cards now. Drawing a king from 151 cards. Now tell me what is the probability of A given E1. A given E1 is nothing but drawing a king, given that there are one last card is already a king. Last card already king is nothing but you have only three kings now. So three kings out of how many cards? Out of 51 cards. So 3 out of 51. Now tell me what is probability of A given E2? A given E2 means drawing a king, but last card is not a king. If last card is not a king, some other card will be lost, right? If other card is lost, then already four kings were already there. So therefore, we have four kings out of 51 cards, now 51 cards only. So it is understood that find the probability of the last card being a king. Last card being a king is nothing but with respect to E1 you will have to find. Therefore, what is probability of E1 given A? Probability of E1 given A is equal to probability of E1 into probability of A given E1 divided by same thing, right? Total probability. Probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So when you substitute all the values, what is probability of E1? Probability of E1 is equal to, right. So probability of E1 is equal to how much? E1 is 1 divided by 13 into probability of A given E1 is equal to 3 divided by 51. Right? Whole divided by same thing. Yes. 1 by 13 into 3 by 51 plus probability of E2 probability of A given E2. Probability of E2 is equal to 12 divided by 13 into A given E2 is equal to 4 divided by 51. So the numerator is going to be 1 3s are 3 divided by, because 13 51 will be cancelled anyway. 1 3s are 3 plus 12 4s are 48. So finally what do you get? 3 divided by 3 plus 48 is equal to 51. So 3 by 51 is the required probability. Alright. And coming to the second problem. A biased die is twice as likely to show as an even number as an odd number. What do you mean by that? For example, probability of showing a number 2 is equal to 2 times the probability of a number 1 or 2 times the probability of number 3 or 2 times the probability of number 6. So that is what is, because it is a biased die, it is not an unbiased die, not a fair die, right? So to show an even number as an odd number, so that I am going to answer this problem by taking probability of drawing an even number is equal to 2 times probability of drawing an odd number. So we do not know what is probability of drawing an odd number. Let us take probability of drawing an odd number either 1 or probability of 3 or probability of 5 is going to be some k or x or y, whatever it is. So then what is the probability of drawing 2 or probability of drawing 4 or probability of drawing 6, which is equal to 2 times, right? 2 times k. But we know that probability of drawing 1 and 2 and 3 and 4 and 5 and 6 is equal to how much? Sum of all the probabilities is 1. Now probability of drawing 1, 3, 5. 1, 3, 5 is equal to k. So there are 3 k's and 2, 4, 6. So there are 2k, 2 3s are 6. So 6k, which is equal to 1. 3k plus 6k is equal to 9k is equal to 1. Therefore, k is equal to 1 divided by 9. When k is equal to 1 divided by 9, then probability of drawing 1, 3, 5 is 1 by 9. And probability of drawing 2, 4, 6 is 2 into k is equal to 2 into 1 by 9 is going to be 2 by 9. This is the basic information. Now moving on to the given problem. So what is the problem given here? See, if such a die is thrown twice is nothing but, what are the outcomes will be there, like 1, 1, 2, 2, 3, 3, 4, 4, and so on. Find the probability distribution of the number of sixes. Probability distribution of the number of sixes means, first of all, let us try to find what is the probability of getting a 6. Probability of getting a 6 is equal to what? There is only one 6, right? Out of all of them. So probability of drawing 1 6 is equal to, it is already there. Probability of drawing 1 6 is equal to 2 by 9. If probability of drawing a 6 is 2 by 9, then what is probability of drawing a non-6? Non-6 is equal to 1 minus 2 by 9. 1 minus 2 by 9 is 7 divided by 9. So with this basic idea, now it is drawing twice. What is the probability of drawing number of sixes? Number of sixes is nothing but, see, it is understood that when you are rolling a die, rolling two dice, probability of drawing sixes is nothing but first die may show six, second die may show six. It means it is showing two sixes. That is one case. When you are rolling a die, first die is showing one six, second die is not showing a six. It means one. Or second die is showing six and first die is not showing six. That is also one. So 1 6 will come in two cases. And coming to third case, when you are rolling both the dice, then first die is not showing 6 and second die also not showing 6. It means number of sixes is equal to 0. Therefore, we can examine and classify number of sixes as three cases. What are these three cases? Suppose x is equal to number of sixes. Okay, x equal to number of sixes. So probability of drawing number of sixes is equal to 0. Let us start with 0. Start with 0 is nothing but what? First die is not showing 6 and second die also not showing 6. It means 6 not showing 6 and not showing 6. And what is the probability of not showing 6 here? Is 7 divided by 9. And the second one also not showing 6, 7 divided by 9. 7 by 9 into 7 by 9, 7 sevens are 49 divided by 9 nines are 81. And the probability of drawing 1 6. 1 6 is nothing but what? First die is showing 6, second die is not showing 6. Or else first die is not showing 6 and the second die is showing 6. It means die is showing 6 is nothing but 2 divided by 9 into not showing 6 is equal to what? Not showing 6 equal to 7 by 9. So 2 by 9 into 7 by 9 plus 7 by 9 into 2 by 9, both of them are same. So I'll just write into 2. How much you get finally? 2 sevens are 14, 14 2s are 28 divided by 81. This is probability of drawing 1 6. Now probability of drawing two sixes. Two sixes are nothing but what? X is equal to 2. Means first die is showing 6, second die also showing 6. So this is going to be 6 gamma 6. What is probability of drawing is probability of showing 6 is 2 by 9. 2 by 9 times 2 by 9, 2 2s are 4 divided by 81. Now I am going to draw probability distribution. So this probability distribution will be now x values either 0 sixes or 1 6 or 2 sixes. And what is the probability of x? When 0 sixes comes, what is the probability? 49 out of 81. 1 6 comes 28 out of 81. 2 sixes are come 4 divided by 81. So this is what is the probability distribution table with the random variable x. And after that, you are asked to find what is the mean deviation also, right? What is the formula for expectation of x, which is equal to sigma xi into probability of xi. Xi into probability of xi, this is xi. 0 into 49 by 81 plus 1 into 28 by 81 plus 2 into 4 divided by 81. 0 into anything equal to 0. 1 into 28 is 28. 2 4s are 8 divided by 81. So 28 plus 8 is equal to 36 divided by 81. 36 and 81 can be cancelled by 9, right? 9 4s are 36, 9 9s are 81. So 4 divided by 9 is the required probability. So that is what is expectation of x, or what is that? Yes, expectation of x. Probability distribution of x, which is going to be 4 divided by 9. So this way you can answer 3 marks problem. So 3 marks problems are not looking that easy, but when you try it, you can understand, you can do it, but be very careful. Coming to 38th question, which is a case study based question. It's a direct problem. Once you observe what is the case study based question here. So in this particular question, Rohit, Jaspreet and Alia appeared for an interview for 3 vacancies in the same post, right? So the probability of who is that? Let me just erase this part. Yes. Now coming to this, the probability of Rohit selection is 1 divided by 5. And who is the next person? Next person is Jaspreet, right? and Jaspreet's selection is 1 divided by 3 and Alia's selection is 1 divided by 4, the event of selection is independent of each other. What do you mean by independent of each other? Independent of each other is nothing but we cannot expect any chances for between 2 or between 3. Okay, that is what independent selection. All right. So what is the probability that at least one of them is selected? So before that, let us say E1 is the event of selecting Rohit. Rohit, no? So probability of R, for example. Probability of R is equal to 1 divided by 5. So Rohit selection is 1 divided by 5. Then what is the probability of not selecting? Rohit is not getting selected. So that is going to be 1 minus 1 by 5 is equal to 4 divided by 5. This is probability of Rohit is not getting selected. And second one is Jaspreet. So probability of Jaspreet is getting selected is equal to 1 divided by 3. Then what is probability of Jaspreet is not getting selected is 1 minus 1 by 3 is equal to 2 divided by 3. And the third one is the event of selecting Alia. So probability of Alia is getting selected is 1 divided by 4. That implies probability of Alia is not getting selected is 1 minus 2 by 3, which is equal to 1 by 3. So we have with relevant information. After that, what is the problem given here? So the problem given here is, this is the information required. And the problem given here is, what is the first question given? First question given that, what is the probability that at least one of them is selected? What do you mean by at least one of them is selected? Means at least one means one or more than one will be selected. So what is the probability that all of them are selected? So if you find out the probability that all of them are selected, then if you subtract that from 1, you will get none of them is selected. Sorry, if you find the probability that none of them is selected, means what? Probability of none. Probability of none of them is selected means what? Rohit is not selected, as well as Jaspreet is not selected, as well as Alia is also not selected. That is going to be 4 divided by 5 times 2 divided by 3 times 1 divided by 3. Right? So this is what is probability of none of them is selected. 4 divided by 5. See here it is 4 divided by 5, 2 divided by 3 and 1 divided by 3. Right? Sorry, this is 1 by 4, right? 1 minus 1 by 4. Small mistake here. All right. Probability of A is 1 by 4. So 1 minus 1 by 4. What is 1 minus 1 by 4? 1 minus 1 by 4 is equal to 3 divided by 4. So this is going to be 3 divided by 4. Right? So 3 by 4. Now see what is the selection. This is what probability of no one is getting selected. So 4 and 4 gets cancelled, 3 and 3 gets cancelled, left with 2 by 5. If you subtract this 1 minus probability of none is nothing but at least one will be selected, right? Yes, 1 minus 2 by 5. 1 minus 2 by 5 is equal to 3 divided by 5. This is what is the probability of at least one of them will be selected, right? This is about the first problem. And coming to the second one. What is second one? Find the probability of G given H complement. Probability of G given H complement, where what is G? G is Jaspreet and H is Rohit. So basically what is, let us convert it into our terminology. Probability of Jaspreet as well as H is equal to Rohit, right? So Rohit is not getting selected. What is formula for probability of E given F? E intersection F by probability of F. I'm using the same formula. So probability of J intersection R divided by probability of R. But see, in the very beginning, problem given that they are independent of each other. Independent of each other is nothing but when two events are said to be independent, P of E intersection F is equal to P of E into P of F. Similarly, E and F are independent, E and F dash also independent. So that we can say P of J intersection R is going to be P of J into P of R bar divided by P of R bar. So both gets cancelled, right? Which is equal to P of J. P of J is nothing but probability of Jasprit. Probability of Jasprit is getting selected is 1 by 3. This is what is the answer for the second problem. And coming to the third one. So what is third problem given here? Find the probability that exactly one of them is selected. What do you mean by exactly one of them? Probability of exactly one of them means what? Jasprit is getting selected, but Alia is not getting selected as well as Rohit also not getting selected. Otherwise, Jasprit is not getting selected, but Rohit is getting selected, Alia is not getting selected. Similarly, Jasprit is not getting selected, as well as Rohit is also not getting selected, but Alia is getting selected. This is what exactly one of them is getting selected, right? Now you have all these probabilities. Probability of J is equal to what? See, I am taking probability of Jasprit is 1 by 3 into Rohit is not getting selected. Rohit is not getting 4 divided by 5 and Alia is also not getting selected is 3 divided by 4 plus probability of J complement is 2 divided by 3 but Rohit is getting selected. Rohit is getting selected 1 divided by 5 and Alia also not getting selected 3 divided by 4 and Jasprit is not getting selected is 2 by 3. Rohit is not getting selected 4 divided by 5, but Alia is getting selected is 1 divided by 4. Okay, so when you simplify this, what do you get? Now there is this part. All right. See, when you observe, these are simple to calculate because you do not cancel them because all the denominators are same almost, right? So that if you cancel them, again calculation part will be more. So that is why what am I going to do? I just multiply the numerators. 1 into 4 into 3 is equal to 4 3s are 12 divided by 5 4s are 23s are 60 plus 2 3s are 6 divided by 60 as well as 2 4s are 8 divided by 60. So totally how much is this? 12 plus 8 equal to 20 plus 6 is 26 divided by 60. 26 by 60 is equal to 2 13s are 26 and 2 30s are 60. So 30 by 13 is the probability of exactly one of them is selected. Now, third question, internal choice, find the probability that exactly two of them are selected. It is same. Exactly two of them are selected means what? Probability of, for example, Jaspreet is selected, Rohit is selected, Ali is not selected. Otherwise, probability of Jaspreet is selected, Rohit is not selected, but Ali is selected. Probability of Jaspreet is not selected, but Rohit is selected and Ali is selected. So these are the cases when exactly two of them are selected, right? So probability of Jasprit is selected is 1 by 3 and the Rohit is selected is 1 divided by 5 but Alia is not selected is 3 divided by 4. Similarly, Jasprit is selected 1 divided by 3, Rohit is not selected is 4 divided by 5 and Alia is selected is 1 divided by 4 plus Jasprit is not selected is 2 divided by 3. Rohit is selected, which is going to be 1 divided by 5, right? And then Alia is selected 1 divided by 4. So when you simplify this is 3 plus 4 plus 2, 4 divided by, same thing, 5 4s are 23 are 60, which is equal to 4 plus 2, 6 plus 3 is equal to 9 divided by 60, which is equal to 3 3s are 9, 3 20s are 60. 3 divided by 20 is the probability that exactly two of them are selected. So this is about paper 65 of 4 of 1, I think. So in this paper, you can find out some interesting questions. The third one is not at all basing on what is that Bayes theorem, but you can answer this clearly if you have an idea about independent units. So hope you understand. So this way you can answer these questions. Thank you.